Hello everyone, my name is Alexandra, this is Emil and this is Jonathan, and we are going to talk about HEART. HEART stands for Health, Evaluation and Awareness Using Reliable Technologies. So what is HEART? Basically, it's a scalable platform in the sense that you may integrate various sensor types as well as sensor manufacturers. The purpose is to measure and monitor physiological parameters to reliably detect and alert in the event of a health deterioration. The alerts are made to the surroundings in the form of visual and auditorial warnings, and a future application can be in retirement homes or for personal monitoring at home. And we built a test application to evaluate the technologies. And for example, we calculated heart rate and evaluated the presence of arrhythmia. And we did that using data from ECG from Shimmer. And how did this idea come to be? Well, the School of Innovation, Design and Engineering is involved in research within the field of medical technology. And from the school, Ivan Tomasic and Nikola Petrovic presented a project proposal, which we chose to participate in. In total, we were 8 students from the Dependable Systems program, and we got the opportunity to take forth a measurement product within the field of medical technology while focusing on dependability. And the 8 students who participated in this, you can see over here. And apart from us standing here, we also have Johan, the chief engineer, Naida, hardware team leader, and Petter, software team leader, and Susanne, validation and verification team leader, and also Al, the quality and process assurance engineer. Most of them are here today, and they will be joining the demonstrations after the presentations.
Yes. So why do we need to build a dependable system? In the year of 2016, 31% of all global deaths are related to cardiovascular diseases. That's almost 17.9 million people. If we're gonna build a device that is monitoring and measuring the health conditions of a human heart, it needs to be dependable. For us, dependability is 3 main things. But in other cases, it can be other things because it's used as an umbrella term. Availability, the system needs to be up and running all the time. Reliability, the calculations and measurements made must be accurate. And also safety, you need to be able to alert when necessary. All of this comes down to trust. The people need to trust the system, the doctors need to trust the system, and so. This is an illustration of the process that we have taken during this project. I think it's hard to see on this display, sorry. But the main thing is that from the proposal we had, we could define an item definition, that is called, with the system boundaries and the intended functionality. With that, it's possible to assess the risk in the different operational modes and also analyzes the failures and causes of that. That provides us the foundation to build some goals that is called safety goals. And from those, it's possible to make the requirements for the system in order to function as intended and with that dependability in mind. This is why standards exist. It provides the foundation and transparency needed for us to build a dependable platform. It also provides a good tool to document and follow different steps and guidelines in the standard. With that, we can ensure that the product that we are developing reaches the safety goals intended.
Okay, so one of the main outcomes of our project this year is the software platform that we have developed. This is implemented as a microservice architecture, which gives us 4 main advantages. First off, it reduces complexity in implementation per service. Although the system grows more and more complex, implementing one specific service will only have one specific task to implement, and it will also have well-defined inputs and outputs. Secondly, we gain scalability, since each service can be either duplicated or replicated with separate functionalities or added functionalities. For example, reading a different sensor type but using the same service to do that. There's also independence, and since all services are running independent from each other, any fault in the service can be contained to that service and hopefully not propagate to the other services. And also there's the factor of redundancy. Apart from the sort of redundancy that is gained from duplicating services, hardware redundancy can also be achieved by distributing services on different hardware platforms. And this can be configured depending on the needs of the current installation. So, during the project we have been using modern and recent technologies. As software framework we have been working in .NET Core that gave us very crucial cross-platform capabilities. It also provides scalability and easy adding of new functionalities. It is also well supported and has a large community. For service communications, we have worked with gRPC, remote procedure calls, to build connection between the services. gRPC is both cross-platform and cross-language, which was important to us. It also gave us the possibility to create well-defined interfaces between services. And it's also relatively easy to implement. At runtime, the intention was to use Docker to enable each service to be run in an isolated container. And the Docker container is somewhat like a virtual machine, but it's more lightweight, since you abstract the application layer and not the physical hardware. It also gives easy deployment on the hardware you want to implement it on, since you pre-build your images on the development environment. Okay, so here are two setup examples. To the left we have a relatively simple example for illustrational purposes. And on the top there we have a sensor data acquisition service. And this service only handles the connection to the sensor with Bluetooth connection. And it then collects and processes that data and sends it on to the next service, which in this case is a patient health evaluation service with heart rate capabilities. This kind of service could have other capabilities as arrhythmia detection or cardiac arrest detection. But in this case, it's heart rate. So when the heart rate is calculated, it's then passed on to the next service in the chain, which is a service responsible for connection with a mobile device. And this service forwards the information to the mobile device, but can also be used to take requests from the mobile to conduct a specific task or transfer any other kind of data. And to the right, we have an example of how you could make this system more reliable. To the right picture, we have duplicated the services, so it's a multi-service system with the data acquisition service distributed on two hardwares. And then we have duplicated for example, so the heart rate and the mobile application service chain onto two different hardwares as well, which both utilize both inputs from the data acquisition. So this would give a fail-safe but with degraded functionality implementation.
As both Jonathan and Emil implied, the project is in a conceptual phase. This is the first time the project is running, and documentation has played a major role. The students who participated in the project have laid the foundation for future development to come. And we would like to thank you all for your attention. Any questions?